data is our DNA. Data is a core part of what we do every day. And we have an incredible group of folks that are just brilliant about finding ways to leverage that data to do new and interesting things. A great group of data scientists, a great group of application developers who take and build incredible data products. But incredible data products are really about the use of that data. The management of it in the background is an incredible challenge. And at Capital One, what we're doing is at a scale that is much bigger than two people with spreadsheets.
Exactly.
And it takes a lot of tools to make that happen. For example, on a daily basis, my team manages about 12,000 different data feeds on the inbound side, publishes to somewhere in the neighborhood of 19,000 target production tables. And this is literally hundreds of billions of rows of data on a daily basis, many of it even a 5-minute or under basis. And the challenge we start to deal with and we start to think about is that we have these really new and modern things like the auto finance API, or if you're here earlier, Paribus. But we also deal with vendors that have mainframe technologies that are older than many of us in the room. So we have data that's at both ends of the spectrum. You have this mainframe episodic data, you have modern JSON files, and they come at different frequencies, different times from different places. Now, how do I put it all together? And that's really the magic of what we're talking about here, and why we built this product. A lot of times you'll hear this referred to as ETL, extract, transform, and load, or data enrichment, or data integration. But it's a process of putting together those, spreadsheets, or billion-row files, and getting them to those analysts who do those brilliant things with them, getting to those data scientists who are making incredible products that we all leverage every day. And that's why we were passionate about, partnering and bringing something like this to everybody moving forward, so everybody doesn't have to buy commercial software to do this type of thing. So that was our goal.
Excellent, excellent. With Hydrograph, now you're open sourcing Hydrograph. Why did you decide to open source it?
Yeah, it really was around that. The idea that I ended with right there was that there's fantastic commercial software in this space. There's things we use, and we use a little bit of everything, but things that you can literally spend millions of dollars a year on licensing that'll do this really well. But we wanted to really build something extensible. We wanted to build something that everybody can contribute to. It's part of really what we're aiming for, is to be a part of the community and really have something that everybody can leverage, everybody can contribute to, and have it be free and open for all.
Great. Well, and that's very much in the in the spirit of what we're seeing today with at-scale application development, deployment, and management, isn't it? It's where we're seeing this real need for communities to come together to actually develop these technologies, because you may be working with different people from all kinds of different organizations, but even people move around, they go to different jobs or whatever, they can still work on these projects and still move forward, because everyone is really needing these technologies to bring together data from disparate sources.
Yeah, and the fact is that things are advancing so quickly. There's so many different technologies available now. If you think about even the world of databases and what's being offered on the cloud, the ecosystem keeps expanding. And everybody should be able to add in the things they need from both a source and target standpoint, from a data manipulation standpoint, and hopefully we're able to offer some things that others can leverage, and others are able to contribute to the product, the things that get a little ahead of the game for us. So I think in the end we'll all win.
So William, I know we have a demo. Maybe this is a good time to do that.
Sure,
yeah, we can
definitely.
Flip to that point.
All right, so let me walk you guys through a demo. I'll also be downstairs later after this talk to show you a live demo, if you want to play with it as well. But let's take a look at some screenshots I've captured here, and there should be pieces of it in here that should look familiar to anyone in the various skill sets, because we are bridging traditional ETL on modern technology. So at a first look, this is our launching Hydrograph. You'll notice different aspects of the GUI that we have displayed here. And they should look very familiar to some folks' experience with ETL technology. But if you look at the top left, we have sort of these, what we call building blocks to create our graph. And the main thing here is that you can work on here and execute locally and also sort of deploy what you're built into production. So the idea of Hydrograph having a UI is for developer productivity. And I have a bunch of screenshots here. I'm just going to go through some of them. Obviously, this was the top left, some components. These are plug and play. And these are areas that we encourage folks to contribute to leverage in your environment, whatever makes sense there. This should look very familiar to Java developers, is the reason why we chose this stack. It's a direct plug into some enterprise CI/CD practices of DevOps, one of the great features here. This, again, is just the canvas, a little bit zoomed in to the actual graph.
What makes sense is talking a little bit for the people about what this data flow looks like. If you've done ETL development, we talked about munging the spreadsheets. The left to right, if you think about just charting out what you're trying to do when you put something together, you see sources on the left and targets on the right. And William's going to talk about sort of that idea that Alex brought up of, hey, I have these, and we keep using the spreadsheet analogy, but I have files. I have things that I'm trying to bring together to use in some particular way. And this is sort of the way you'd logically think about attacking that type of problem if you were going to, do a flow chart the way you might have in college, like how am I going to solve this problem? This programming interface allows you to start with that same paradigm of, hey, here's the way I think about it, and the solving of that problem really sort of feels the same way in this type of tool.
So would these be the 3 different data sources here then?
Yeah, those are the 3 data sources.
And this is the map then.
Right, and for this particular demonstration, there's one output from this application. And I think, so this is just the console, and then we have some slides to show. So this is what we're talking about, where our input sources are. And then there's very configurable properties we have in these input sources. They're different for various types of input, but just to show some areas that we've made it easy to leverage these reusable components. And then there's also the aspect of how we integrate this with our other services. And the idea is, if you think about it, this is an input data source. We have a particular schema, right? And the beauty of Hydrograph is we expose this as an artifact that can be utilized by downstream or upstream systems. So particularly for us, if you think about what this is, it's more about governance of the metadata of a file, right? What's in the file, what is the layout. So this is very extensible how you can plug it into your environment. We plug this into our metadata governance platform.
One of the key things to add for the idea of metadata and governance is, in the end of the day, Capital One is a bank. We are a bank that's managing a massive amount of data. So it's absolutely critical for us that we're able to protect the things that need protecting. We're able to understand what's in the fields. We're highly regulated, so we need to manage our data very tightly. So plugging into systems that help us do that and having something that it really gives us a structure to do that in a consistent way is why this is critical for us as a bank.
Yep. And then let's walk through some of these. Like we said, these are some transformation components we can pull in. Just show you some of the logic. It's very similar to, each component has different configuration properties. And these we chose as areas for this transformation component. But each one has different, it's sort of like a template to how to create your logic for the manipulation. This is going into more detail. This is a simple one. If you look at what it's showing, basically we want to remove data immediately that we don't need for this application. So it's very drag and drop. Basically those are propagated once you define a schema for your file. And this particular component that we're manipulating is if you look on the left-hand side, we start with 8 or 9 sort of attributes. And just a simple example how we're quickly limiting that down. And this is simple a drag and drop sort of environment. There's a little bit more functionality we can do here. If you look at the top, we could actually do a manipulation of those attributes within this component. So there's a lot of different features that you can leverage. Quickly, who doesn't need to filter out some data? Just a quick yes-no flow sort of idea. We built out that too, so I won't go into all these different interfaces for each component. But just to show, we have some pre-built functions too. You can always load in more yourself. You want to build in some and add them. This should look very familiar to sort of Java background developers. Your Java docs is on the bottom right. And you can create a large variety of functions that your enterprise or wherever you're working in want to reuse. This is the same sort of feature here, just showing different capabilities of the tool. There's a lot of capabilities, so I just pulled out some key ones here that people can relate to and sort of understand from what you want to do of data, right? So this is the same expression that we had earlier. This is just evaluating. So we have some built-in test suites that you can do quickly from the development interface. Just flowing through this example, right? So this aggregate, if you think about it, what if you want to do a running sum, or you want to do a min-max sort of logic? You can do it here. So we thought through all these manipulations and created these set of components. We have around 20 data manipulation components right now, around 20 or so input-output sources. And we found a combination of these. You can manipulate your data to whatever you need in the end result. And obviously, there's a lot of room for adding in your own sort of logic if you want to create something custom, if it makes sense for your area that you're working with, and you want to reuse these components. This is a very similar sort of layout. You saw this a little earlier, right? It's a great way to sort of drag and drop your interface. So consistent interface here, right? You see these are the exact fields that go from input to output. But if you look at what we're doing here, right, I'm doing a sum of the payments. And I didn't show you this on the previous screen, but you can actually set your keys you want to use. So in this account, for this application, we're summing the payments on an account ID. And this is the code snippet. I won't show this for too long, but this is some of the custom logic you can also build in. If you're familiar with Java, we basically have these templates that you can fill it in. And when it executes, it knows to pull these in. Once again, we'll just run through an example. So here's a join. Join is quite simple, right? We're just merging two files together. You can choose what kind of join. Also, you can see what fields come in from each of these files. So it's a great visual verification of what you did. And this is sort of the execution environment. You can see here in the bottom left, we're trying to show what has been completed and what is currently running. It runs really fast for this example. So you'll see that we don't have all the statuses, but in the middle, you see those two blue check marks. It means those have completed. And then the timer is sort of where it's still processing. We have ways that you can inspect at different areas. It's a post-run, so if you remember the previous slide, after we execute and see what happens, you can see what went on at every stage of the data movement. And that's some of the key features I want to show. There's definitely a lot more, and I will have the product loaded up downstairs afterwards, too.
Excellent, excellent. So my initial question is, what were the problems that you guys were facing internally that led to this project? What were those major challenges that you were seeing?
Yeah, so one of the things that stands out to me is, we've been doing this a long time. We have 10,000 inputs, many tens of thousands of outputs. And we have a lot of logic that we've built up over the years. And we needed a great target to sort of move from and to. We've got a lot of investment in proprietary software. And as we move forward into the cloud, we wanted a great way to translate sort of this legacy we have into a more modern stack. And one of the things that we found is that when we looked at sort of other offerings out there, we weren't able to cleanly translate. You know, if you're familiar with ETL technologies and saw what we had up there, everybody does it a little differently. You know, so some cases you saw the join component. Some companies who offer a join component will only do a two-way join versus a three-way join or a multi-way join. And you always have this problem of, how do I make this fit into my target model? When we looked at this, one of the things was, if we go open source, we can build it exactly the way we want to. We can, you know, we don't have to try to make it fit into somebody else's model or fit into the model that somebody else had laid out. You know, we can do what we need to do to make that transition clean. We can also offer it to others and have them build in the components as well. So as we're starting to look at these new modern stacks, as we move much of our infrastructure to the cloud, these evolving target technologies and source technologies are another big driver. So the idea that we can get there, we can build the interface to the Amazon Redshift database or Cassandra or Mongo or whatever at the speed that we're willing to move, not the speed the vendor is willing to move. So all of that flexibility was a huge part of this decision, in addition to just wanting to be a sort of a good member of the open source community and offer something that others would, we think, can leverage highly. And again, we're hoping that others contribute back to this, and it's a two-way street.